Redstone Logic Gates are the foundation of almost every advanced Minecraft machine. In this tutorial, I'll show you how the most important gates work and how you can build them yourself step by step. Most gates are actually super simple, and for the negated versions, you usually only need to add a redstone torch to the output. Logic gates take inputs like levers or buttons and create an output. On means true and off means false. Different gates react differently depending on their inputs. To build all the gates you need torches, dust, blocks, redstone lamps, redstone comparators and of course levers. The first gate we will build is the OR gate. The OR gate turns on if at least one input is on. The levers are our inputs and the lamp our output. Now you see how this gate works. Now I build the truth table. The three lines represent the inputs A and B and the output C. The black wool means false and the white true. To build an OR gate, you simply need to add a redstone torch to the output of a normal OR gate. And that's a finished NOR gate. It simply inverts the output of an OR gate. And that's the truth table for a NOR gate. Now let's build an AND gate. The AND gate only turns on if both inputs are on. First, we invert both inputs. Then we connect the inverted signals together and invert the signal again, which gives us our output. Now you can see that the lamp only turns on if both inputs are also on. And that is the truth table for the AND gate. For the NAND gate, you simply remove the redstone torch at the output of the AND gate, so you don't invert the signal twice. The output of a NAND gate only turns on if there are less than 2 inputs on. And that's the truth table for a NAND gate. The next gate is a bit trickier. It's called the XOR gate. The XOR gate only turns on if the 2 inputs are different, meaning if exactly one input is on. First, you place 8 blocks in a 2x4 rectangle like this. Then you add 2 input blocks and place redstone dust in this pattern. Next, place 2 comparators and make sure to click each of them once so they switch into subtraction mode. After that, place the levers as your inputs and then add 2 blocks with redstone dust on top in front of the comparators. Finally, place a redstone lamp as the output. So you can see if both inputs are on or both are off, the output is off. Only if exactly one of the inputs is on, the output turns on. And this is the truth table of the XOR gate. And now let's build the XNOR gate. For the XNOR gate, you first build an XOR gate like before, and then you simply place a redstone torch before the output to invert the signal. And that's how you build the XNOR gate. The output only turns on if both inputs are the same, like 0 and 0 or 1 and 1. And that is the truth table for the XNOR gate. So now we have almost all of them, but there's still one left. The NOT gate. It's the simplest of them all, but I'll show it to you anyway. It's literally just a redstone torch, nothing else. And that's a truth table for the NOT gate. It's very small, I know, but it has only one input, so yeah. And those were all the logic gates. So if you want to see more videos like this, make sure to subscribe for more redstone tutorials and Minecraft content. Bye!